Okay, on this one, we're going to deal with an analytical approach to guarantee that a particular function has a point of inflection at the point 1 and -6. So I'm going to flip over to my notepad here and just write down the question that I have. So we have y is equal to x cubed plus ax squared plus bx minus 4. We have a point of inflection, so I'm going to say POI at 1 minus 6. And we need to make sure that we can get that point of inflection by choosing some value of b. Don't know what that value of b is yet. But what we do know is the second derivative at 1 should change signs at x equal to 1. So we need to figure out the second derivative. So the first derivative, we get 3x squared plus 2ax plus b. And if we take the second derivative, we have 6x plus 2a. And we notice that b doesn't change anything at all in this problem. So in here, we need to make sure that y double prime at 1 is equal to 0. That's going to guarantee what a is. And we'll come back to how we're going to choose b. We're going to choose b to make sure that it passes through the point -6. So if we solve this right here, this says 6 plus 2a has to equal to 0. So we then have concluded that a is equal to -3. That means our original function is now x cubed minus 3x squared plus bx minus 4. And so all we need to make sure is that if we let x be 1, that y does equal to -6. And that'll choose what b must be. And so at x equal to 1, I get 1 minus 3 plus b minus 4. We get -7 from these two. We get a 1. We get -6. So it says -6 is equal to -6 plus b. And therefore, we've concluded that b must be equal to 0 in order to have an inflection point at 1 minus 6. So let's review. If a is equal -3, then we have an inflection point at x equal to 1. If you choose b equal to 0, then you have a point of inflection that has a value of -6.